Hello, my dear students. Welcome back. It's been a long time. I hope you're watching the other videos which I am uploading for you. So I thought that since we started this chapter 5 online classes and all, so I just thought that I'll wind up, we'll finish up the differentiation part live class. So since we started live, let's finish it up live also. So it's good to have you back, all of you. We have some questions. It's not going to be, I believe, a very long class today. We have about maybe around about 7 to 8 questions to solve. So let's enjoy the class. Let's try to finish up the exercise today. Because after this exercise, we'll be having just now another 2 more exercises that will be on application of derivatives. That would be the Rolle's theorem and Lagrange's mean value theorem. So that's like application of derivatives. So this is going to be, of course, the last exercise. So I'm sure that you have come prepared with the other videos. So let's get ready. Bring out your books, pen, paper, and yes, it's good to have all of you back again. Let's get ready. Yes, once again, a very warm welcome, a very warm good evening to all of you. As we wait for some of more of your friends to join in, let's get ready with that question. So, if you remember last video, I have finished up to question number 10. So, let's finish 11. Let's start from 11. I mean. So question number 11 onwards, actually it will depend on not just like, just like blindly differentiating. It will depend on like how you make use of the equations given to you also, and how you do your differentiation. Of course, this is the last exercise, so definitely like whoever comes to this exercise, we expect like expectation is that you are now like very good with differentiation. So I am sure that you are good in differentiation. If not, please do practice. Regular practice is very important. Okay. So you can get the question ready. We are going to begin very soon. Alright, let's just begin then. We have to find out, prove that the second order derivative plus y is this function, is equal to 0. Let's start with the differentiation. So I'm going to just do it directly now. Differentiation of cos x is minus sin x. It's a simple question, but as I said, you have to know how to make use of your equations given to you. Not only just differentiate. No, we really have to be aware of what are the conditions given to us. So this is a perfect example because as we differentiate the first order derivative, then we go for the second order derivative of the derived function. Then since we in the proof you have a function y there, so how to bring that y? So we can see clearly that this function is y given to us. So instead of this function, we can use y. So minus y becomes plus y. We have the proof. So it's a simple proof. Once again, a very good evening to all of you, all those who are joining in. The others, let's get ready with the other question. That's number 12. If y equal to given that y is equal to cos inverse x, our question is find the second order derivative in terms of y alone. So we do not want any functions of x. Let's begin. Let's see what we can do there. That means I do not want any function of x. Okay, so how do? We do not want any values, any functions of x. We want it in terms of y only. So before we really begin, maybe, is it okay if we just use the inverse trigonometric function concept and just cos x, not x, come on, cos y equal to x. I think that's fine, cos inverse, applying inverse of cos on both the sides. So we have already seen this, right? So cos y equal to cos inverse cos, that's identity 1, so that's x. Oh yeah? So now differentiating both sides with respect to x. Remember, you should not be forgetting anything, okay? So like differentiating y with respect to x, implicit functions, don't forget that. So we already have our job done. We can see that even the first order derivative is a function with respect to y alone. So I'm sure that we will not be having any problems when we proceed. Because the thing is that I want the value only in terms of x, in terms of y only. So therefore, let's go for the second order derivative. So of course minus is there. Now what is the derivative of cosec y? Derivative of cosec y is minus cosec y cot y. But children, please do not forget it is y. So implicit value will come. Implicit function dy upon dx. These are small things which we ignore, okay, most of the times. So, and these things will cost us marks. Please don't do that. So we have here minus minus, that's plus. So we will be having cosec of y, cot y. Now dy by dx, if you wish, you can mark this as equation 1. So dy by dx, I can replace it with minus of cosec y. So minus of cosec y. If you wish, you can write on like from 1. So ultimately, the second order derivative can be written as minus cosec cosec. So that's going to be cosec square y cot y. So we have the value of the second order derivative only in terms of y. So as you can see, right from the beginning, you have to do it carefully, right from the start. Minus cot y into cosec square y. It's not that it's not possible if you don't do it right from the beginning, but you know how easy it has become. If you do not do it, then you may have some problems, converting, because we want only in terms of y, so maybe you might have to do a lot of trigonometric applications. So I guess this will be much easier. Alright, the next one, that will be number 13. Four sine numbers. So this function, we will have to prove that x square y2 plus x y1 plus y2 is 0. So in the previous video, I've already told you that y2 represents the second order derivative, first order derivative, the function. In other words, another way, we can also write it as this one. So this is what we are supposed to prove, that this value is 0. Alright, so let's begin differentiating both sides with respect to x. Derivative of cos x is minus sin x, but the chain rule will follow derivative of log x. I believe you have written this. I'm going to rub this part. If you have not, this is important just for you to understand what you are going to prove. And now proceeding with the chain rule, that is derivative of log x will be 1 by x plus, for derivative of sin x is cos x. Continuing with the chain rule, derivative of log x is 1 by x. Now dy by dx, I can write it as y1 because that's how the proof is in our question. 1 by x, I'm going to take common from both the terms. Is that fine? Now let's proceed with our second order derivative. Derivative of sin x is cos x, chain rule, log x is 1 by x. Same here also, derivative of cos x is minus sin x, chain rule, log x is 1 by x. Because here I'll have to again apply the product rule and then continue. I just can't leave it as it is. I hope you're done with the first part. So it's 2 cos log x plus 4 sin log x. We might just need this. Okay, so in that first equation, you can just mark equation 1. Alright, I'll continue. So I'll continue with the product rule here. I'll take minus common from both the terms, 1 by x common. So if you mark that first function given to you as equation 1, then the first order derivative, you mark that as equation 2. I think we marked it as equation 1, isn't it? So you can just change that to equation 2, okay? Now this would be derivative of, this is what? The first order derivative. So if you differentiate that again, what do we get? The second order derivative. I guess you are clear, isn't it? I'm sure that you have gone through the first video. Now, along with that, I'm going to do it here itself. This x I'm going to multiply it up here. Just cross multiply. Equal to minus. Now, if you look at the question, I think this is the function y that's already given in the question from equation 1. Three cos log x. Now, dear children, as I said, the first equation that is given to you, you should mark it as equation 1. And that first order derivative, please correct that equation 2. Okay, otherwise you'll be confused again when you write equation 1. Alright? So now if we just multiply, bringing this minus 1. So that's it, you have to prove. So that's why you need to be very systematic. Okay? There is actually rain falling down, so I believe that it's not bothering you. I guess we can continue. I guess all of you can hear me loud and clear, right? Is it okay if we just continue? I think it's not disturbing you at all. Yes, my dear children, is everything fine? I hope the rain is not disturbing you. It's just that, okay, I'll have to talk a little bit louder, that's all. Alright, thank you, good to hear that. We don't have many problems to solve, just 1 or 2 problems to solve left. Let's finish it up, okay? Alright, we can note down the next question then. Alright, thank you for your response. That gives me the confidence to continue. Let's continue. So we have the proof. I'm not writing down the proof. The second order derivative minus m plus n into the first order derivative is equal to m into ny. I believe all of you have your textbook. So do I need to write down that question? I think it's alright, isn't it? Okay. So let's start with the proof. Simple proof. A is a constant. Derivative of e power mx is e power mx. We'll just proceed with the chain rule. Now derivative of mx is m. Do I need to write down? I'll just show you the rough. Okay, I don't want to be writing too many steps. It's like something like this. Come on, this is the last exercise. So that's like a into e power mx derivative of m into x. So definitely that's a into e power mx. M derivative of x with respect to x is 1. So the same thing goes here. So if you are really connected with differentiation, just this one, that's enough. Okay? We do a little bit of arrangement. See, all the questions the proof cannot be just derived directly the way we have been doing for the previous questions. There are some questions which are quite complicated, so in those cases, you just got the question 1, 2, and 3. And then just go to the equation, take the left hand side, get the proof of the right hand side. That way also you can do. Alright. Certain questions in which we can directly just proceed and then get the proof done, no problem. If you think it's getting too complicated, it's alright, you get the first order, get the function, get the first order derivative, get the second order derivative, and then just combine the left hand side or the right hand side of the proof. You'll have the proof as long as you're doing it correctly. Okay? So this is what I'm going to do here. Now let's get that equation. What was that equation? So I'm going to rub this part. Now, okay, let me get the left hand side of the equation, that is this value we have to prove that it is 0. Alright, is equal to, I am just going to write this one, second order derivative. Minus m plus n into the first order derivative plus m into n the function. Because you can just write down using 1, 2 and true. So now your job would be simply to just multiply and see for yourself that it is the proof, that the proof is 0. So just multiply and solve and see. I'll continue here for myself. It's getting interesting here. I think that's alright. Multiplying. If you're done with this, I'm rubbing this part. So 1, 2, 3, 4, last is minus. Okay. Alright, let's see if we can cancel certain stuffs. This gone, this gone. N square, maybe there. M N A E N X out, out. M N D E N X. You see? Sometimes that's why, sometimes we just from the function, just like the previous questions, we may not be able to get the proof done. Okay. But in that case, it's alright. You just take the function, the first order derivative, the second order derivative, go to the proof, take the left hand side or the right hand side, get the proof done. So here we are supposed to show that the second order derivative is 49 times of y as the function. So most probably we might need this equation. Using chain rule, derivative of e power 7x is 7x into chain rule 7x is 7. I think this might be a very simple question, okay? So I'm just going to straight away now just go for the second order derivative, alright? 7 to all this right here in the so continue with the chain rule, another 7 will come. Because this one again I'm going to differentiate, so this is already up here. Into 500. Let me just write into 500, e power 7x, derivative of 7x is again 7. Same here, minus 7 I'll write. Into 600, into derivative of e power minus 7x, same. Minus 7 comes. Remember the question we had this, 49. Always be on the lookout for what is your proof also. So we had this 49. Now you can see 7 sevens are 49. If I can just take this 49 common, I think this is just going to end up here. E power 7x minus minus, we already have plus, so that's like 600 e power minus 7x. I think that's already equation 1. So that's like 49y. So nothing much here. More simpler than I expected. Well, let's go to the last second question, number 16. This happens very rarely with some questions only, but we know that both the left hand side and the right hand side are completely two different meanings. Just for this function, the proof holds, that's all. Okay. Anyway, we'll have to prove, so let's prove. I think that's clear. I've just written some extra steps for you also, because just following with the product rule, we all know this. Just be careful here, as I repeat again and again. Be careful with the implicit functions. Derivative of e power y, that's e power y, but the implicit function dy by dx. Otherwise, you will not have this first order derivative. Just be careful there. After that, this one I just multiply directly. That is already just e power y only. I took that to the other side. Just save some steps. Then this is a common factor, cancel it, minus 1 by x plus 1. That's the first order derivative. Keep an eye on this. And I'll proceed with the second order derivative. If you're done, may I rub it off? I'll have to use quotient rule here. Without quotient rule also we can do. Not a big deal about that. So many ways in which we can do. So we'll use everything that we've learned so far. So minus is already there. This one I'm just bringing it on top. That is x plus 1 whole power minus 1. We can just apply chain rule. Not a big issue there. minus minus, I can just write cancel plus. Okay. Now I'll just write this here. I will be needing this. Okay, now see, have a look. You know the proof, isn't it? What we're supposed to prove, right? Now, this one, this term, can I just write it as like this? Is there anything wrong if I write it in this manner? It's x plus 1 whole square, so it's just mod, because I know that this is the first order derivative. Look at the proof. My proof is the second order derivative is equal. Sometimes we have to innovate. The square of the second order derivative, first order derivative. What is the first order derivative? Minus 1 by x plus 1 x plus 1. So this 1 by x plus 1, just in line with this, in alignment with this. This one, can I just write minus 1 by x plus 1 whole square? Everything is same because minus 1 square is 1, x plus 1 whole square is x plus 1 whole square. But when I do this, what happens is this function is dy by dx whole square using 1, not using 1, from 1. So that's it, that's our proof. Okay. Alright. Okay, now let's move on to the last question for the day. So this is the last question for today, so it's going to be a short video. We're going to wind up very soon. So, as always, can I have likes for this video if you like the video? Because today I think we already have, okay, it seems like some people did not like our video today. Maybe because of the rain, I guess. So with this, we have to show that okay, this is what we have to prove. Okay, somebody just disliked our video again. Likes, dislikes, push and pull, push and pull. Shall I like? Shall I dislike? It's up to you. It's up actually about if you have enjoyed the video, if you've learned something for the video, a like would be, I would be much humbled. Yeah, for it's good for my motivation. If you dislike, then I really can't say it because it doesn't really matter also. But likes, yes, matter. Dislikes doesn't matter much because we may have our own, decisions. I truly respect that it's subjective. So some may not just like the lights, some might just not like the rain, some might just not like me. But likes, yeah, it's a good sense of motivation for us. But doesn't matter, as long as we learn, that's it. As long as we get good marks in the examinations, as long as we become successful in the future, as long as we learn from what we are trying to, from each and every class, yeah, that's what matters at the end of the day. Okay, our dislike has increased again. He has again chosen to dislike again. Chalo. Okay, anyway, just keeping the jokes apart, let's go back to this question now. The last question. Y is given so such that we have to, show that this is a function. Anyway, let's just begin. So the first order derivative dy by dx is equal to, so chain rule, we are going to proceed with chain rule again, so that's going to be twice of tan inverse x 2 minus 1. Last problem, so I'll write down the steps, some of the steps. So this will be represented as y1 twice of tan inverse x 1 by 1 plus x squared. So if I can, because by looking at the proof, that's why I have been telling you, just always keep an eye on the proof. X squared plus 1, so I'll just multiply this. 1 plus x squared y1 twice tan inverse of x. So this is the first order derivative. I think we'll get the proof from here. Anyway, we'll just mark this as equation 2. Just in case we need, that function, you please mark as equation 1. Just in case we need it, okay? Okay, today my dislikes are increasing. Number 3 now. Somebody is liking, disliking. करते रहो, क्या है, no problem. Anyway, just let's try to learn. So after this, first order derivative is done. Let's go to the second order derivative. Let's differentiate this once again now. So here, of course, we'll have to use now product rule. Listen to this. I'll just write all the steps as I said, last question. So derivative of tan inverse x is 1 by 1 plus x squared. I don't think we are going to need this equation. Okay, so I'll just wrap it up. This one also I don't think we are going to need. y2, y1, this will be 2x twice by 1 plus x squared. So now I think if you just cross multiply this, then we'll have 1 plus x squared, 1 plus x squared, we will have 1 plus x squared, 1 plus x squared, the whole square y2 plus twice x y1, 1 plus x squared is equal to 2. That's it, that's all done. It's not actually a very difficult exercise, okay. Alright, so it's not a very difficult exercise. So, that's it for today, my dear children. So that somehow sums up the differentiation. After that, we will have just the applications of differentiation. Applications, the roles, Lagrange's maxima, minima, tangent, slopes, approximation, and many more. So that's it for differentiation. Maybe next up we will try to pick up this Rolle's theorem and Lagrange's mean value theorem. All right. So thank you so much for being with us. I hope you have learned from this video. Do practice well, do stay safe, and take good care because time is running away, exams are approaching, so please work hard, work hard, work hard. All right. So till then, all right then, see you. Bye bye, each and every one of you. Take care. Good night.